So hi engineering Janta, I am Vaibhav Shukla and today we'll continue the day 5 for the DSA for placements in 7 days, and I can see you guys interacting here on the live chat. So go ahead and tell me if I am visible and if I am audible to all of you so that I can proceed further with it. Tell me in the live chat section if you can see me, if I'm visible, if I'm audible. Tell me that. फटाफट बताओ. If I'm visible, if I'm audible, tell me. Then we'll go ahead. So if I'm visible and if I'm audible, go ahead. Tell me in the live chat and then we'll start with it. Great, great. So, hi Shravani, hi Epic One, hi everybody, hi Junnu, hi Bhavyam, hi Yogesh. Okay, I'm Krishna sir. Okay, hi Krishna. Fine. So, first of all, before I begin with today's session, you can go ahead and follow me on Instagram and you can directly interact with me here. And this is my handle @Shuklaji Speaks. You can come and you can talk to me if you have any problem regarding anything. Fine. And in a while, the CST team would be pushing forward this Instagram link of mine as well. So Utkarsh, if it is you who's moderating, please put the link to my Instagram profile so that students can get it. See, super fast team. So these guys added the link here itself. So the latest link that you have can easily go ahead. You can straight away go and actually connect with me on Instagram. Now, I'll be very clear with all of you who have been consistent here. We have already covered so far arrays. Fine. Okay, so Anil is first time here. No issues, Anil. You'll still learn a lot. Fine. Arrays, and we had learned hashing. Fine. We have already done stacks. We have done queues. Pardon, not queues. We have done linked lists. Fine. We have done linked lists. Fine. Along with this, we have done 2 pointers as well. Fine. And today, a very important topic would start, which is trees. And today I'll give you, in last class, I haven't given any homework. Good evening, Vibhuti. I haven't given any homework in last class. So today, in today's class, I will give you some homework as well. Fine. So you'll get some homework in today's class, which would include not some homework, I would say a lot of homework. Fine, because last class had no homework. So you enjoyed. Today, everybody would have the same penalty as well. Okay. So moving ahead, we have at our end trees. Fine. What are trees? So if I say it in very crude term, then it is a cyclic undirected graph. Okay. What is graph? A combination of edges and nodes. Okay. So if I say something like this is a tree, wait, I'll show you. So something like this is a tree. Okay, this is called a tree. Now in this tree, it might look like this as well. Fine. So no certain boundaries. We'll talk about the type of trees as well, which are the most important ones for placement. Only I'll explain those trees. Fine. Along with that, remember that any kind of tree that you're using would always be super important for your placement. The reason is a lot of questions, a lot of concepts revolve around trees. Okay. Now, to say the very basic, this is node. Fine. And this is edge. Okay, edge. These are also called vertices. Fine. These nodes are also called vertices. Fine. Now in this, if I tell you that all these nodes which are connected with edges, they have some depth or distance. We'll talk about it in detail as well, but this particular structure combined is called a tree. Okay, a lot of time it is used for various purposes, and today we'll explore some questions over it. We'll learn how exactly you can use these trees. Okay, along with that, these trees are primarily the type that is usually asked in placements is binary tree. Okay, and there is one more tree which is binary search tree. A lot of students remain confused. What is binary tree? What is binary search tree? They sometimes mess things up. So for today, once and for all, I'll clear this out to everybody so that you guys can actually do things well. However, before I go further, I'll explain you two things. Such node where you have children is called root node. Fine. And this particular node which has no further children, this is a parent node, these are children node or child nodes. If you have no child node ahead, then this is a leaf node. Fine, this is called a leaf node. Okay, so these are very basic things that you should jot down about trees, about binary tree, and about any kind of tree. Now if I talk about binary tree, fine, if I talk about binary tree, any tree that has at most 2 child nodes, fine, any tree in which, I would say, in which every root has at most 2 child nodes. That is a better definition. Fine, why am I saying so? For example, if I say this, is this a tree? Is this a tree? Yes, it is a tree, but not a binary tree. Why did I say so? Because here this root node is actually having 3 child nodes, and I told you any tree in which every root has at most 2 child nodes. So they can be 0, they can be 1, they can be 2, but not more than 2. Fine. So those trees in which at most 2 child nodes are present for every root node, that tree is called binary tree. Fine. So what if I tell you this particular tree? Fine. Is this tree a binary tree? Tell me. This is one. Then for second, I am drawing another example. Fine. Hi Rajdeep. Is the second one a binary tree? And then I'm drawing third one here. Fine. And I'll write it like this. Is the third tree binary tree? Tell me. In the chat section itself, tell me everybody, is the first tree, let's talk about the first tree, is this a binary tree? Tell me. Is the first tree a binary tree? All those people who are watching this, tell me in the chat section, because all these foundations are necessary. Akanksha is saying no. This first one, this I am talking about. Akanksha, is this a binary tree? I have now put a box around it. Tell me. Yes, correct Yogesh. It is a binary tree. Yes, this is a binary tree. Now if I go again to this second tree, is this a binary tree? Check the second one. This particular tree, check it. Is this a binary tree? Tell me. Akansha, focus here. I am saying the second one. This second tree. Now carefully see what is the problem in second tree. Why it can't be a binary tree? It is a binary tree. See, for every root node there is only 2 child nodes. Fine. Mohammed Faisal, why isn't a binary tree? Tell me. For every root node, check. This is a root node. It has only 2 child nodes. Fine. Then further if I go ahead, there are only 2 child nodes or less than 2. Correct? There are no 3 nodes, right? Now if I talk about this particular tree, fine, the third one, is this a binary tree? Yes, only for root nodes you have to check. 3 no sir, correct. This is not a binary tree. The reason being, for this root node you have 3 child nodes, isn't it? Absolutely correct. Absolutely correct. Bahut badhiya. Very nice. Now when you can identify what is binary tree, now I'll explain you something more interesting called as binary. Correct, there are 3 child. Binary search tree. It is a binary tree only, a binary tree in which every left subtree contains values lesser than root, and every right subtree contains values larger than root. Okay, is it clear to everybody? So basically what I'm saying is, if I have this root node and its value is 5, then I have something called as 3, and then 4, and then 2 here, and then here if I come, I have something called as 6, then I have 7, and then I have 8. So if you carefully see, for next class please explain about graphs. 100% Gayatri, in next class we will go for graphs, because right now if we are going ahead with trees, the next thing automatically that is being covered would be graphs. Okay, don't worry about that. Now if you see, this is a root node, fine, this is a root node. In its left subtree, all the values which are present in the left subtree are lesser than 5. All the values that are present in right subtree are greater than 5. Fine. Then I come to 3. When I talk about 3, all the values in its right subtree are lesser than 3. In the left subtree are lesser than 3. All the values present in right subtree are greater than 3. Same goes with 6. All the values present in right subtree are greater than 6. But is this correct? Is the 7 correct? No, 7 is not correct. You need to have some other value here. Fine. You need to have some other value here. For example, if I draw it like this, 7 and then 6. Is this correct now? Correct, Gayatri. Very good. Very good. So everybody got the proper answer to it. Everybody got the proper answer to it. Very good. All of you understood it well. Nice. I'm so happy hearing this. So now it is correct. If you see, 7 is a root node which is actually smaller than 8, which is its right subtree. So right subtree contains larger value and left subtree contains smaller value. But for 5, all the values are greater, so it isn't right. I'm so happy that you guys are getting the concept absolutely. It's so good. Very well done. Fine. So everybody clear with these two concepts? Fatafat batao, then we'll move ahead onto the question directly. Directly we'll go to the question. Are everybody clear with this much concept? Tell me fatafat. Fatafat batao yaar. Bahut badhiya. Very nice. Very nice. Let's now end this show and let's go ahead on the actual question. So there are few questions which are actually considered tough in trees, and not just tough, they're often asked. Most of the times they're asked in some way or the other, so I'm explaining you those questions. For example, this maximum depth of binary tree is asked a lot of times. So I'll go ahead, I'll show you this. So for example, this is a tree. Okay, what is its maximum depth? If you carefully see, what is its maximum depth? If you see, its maximum depth that should come out to be is here. You can go ahead and see this is the depth. Fine. 4 should be the right node. It is not a BST, it is a binary tree. This is not a BST. This is a simple binary tree. Now, what I'm saying is, this 1, then it's 2, then it's 3, and then it's 4. Correct? It is a simple binary tree. Okay? It is not a search tree. Not a binary search tree. Fine. Is it clear? Good. Now what is its depth? 1 and 1, which is basically 2. On website, on the page of 150 not out, it is written 3, so don't worry a lot about it. I'll get it corrected. No issues on this. Okay. But how are you getting this actually? Why are you going to 3? We'll check it out through the code. Fine. Let's examine whether this particular value that we are getting here is correct or not. How exactly are we getting this measure? So let's go ahead and let's check it out through the particular case of it. And I'll use recursive DFS method. I'll use the depth first search using recursion, and the time complexity is generally order of n. Best case, if it is a balanced tree, you have order of log n. If it is worst case, which is skewed tree, on one side only all the nodes are arranged, then you'll have order of n. Okay, so let's go ahead, let's understand the correct value of it, find how to actually check it out. Now what we are going to do is I'm going to define a max depth function. Okay, so what I'll do is I'll take a screenshot of this and I'll paste this inside my slide. Okay, so I'll take a screenshot of it. Okay, and this is my first class. Great, Kavya, if it is your first class you should have started with arrays, but even if you're here, I promise you learn a lot of things. All you need to do is you have to stay focused in the class itself. Okay, so I'm pasting this up and this is my code here. Okay, this is my code. Let's enlarge on it a bit. So I guess it's not visible. Is it visible? Yes, it is visible. Please also use Java. I will explain the Java code as well, don't worry. Fine, I will explain it, so you need not to worry about that. I'm here for you for the same purpose only. Fine, and this somehow or the other is troubling me again as always. So what I'll do is I'll go back here, I'll reduce its size. So I hope everybody can see the whole code now. Great. So now what I am trying to say is, here if you see carefully, I have defined a max depth function. So I did def max depth. Okay, so I defined a max depth function. Now what is it taking? It is just taking the root of the tree. Now whenever you get the opportunity to see the root of tree, I'll show you one interesting thing. Fine, so I'll go back here and I'll show you something interesting. See, when you pass on a particular tree, you pass it like this. You give a root and then you have the whole tree in this order: 1 2 3 null null and 4. What does this mean? So basically it is passed in an order like this. You have 1 2 3, it was 1 2 and then I guess null null, right? And then 3 and 4. Is it? Yes, 3 and then null null 4. So null null and then 4. So what is this basically? This is nothing. This says root. Fine, and this root says this is 1. Okay, then you have here you have 2, which is the left root node, then the right root node, then again the left root node for this left subtree, null. Okay, nothing basically, null, and then you have left subtree which is 4 again. So if I even if I erase it, it doesn't bother me anyhow because I don't have anything. So null is as good as nothing, correct? This is your tree which you're actually getting. Now when I try and figure it out that how exactly I can calculate the depth of it, what I do is I define a function called as define max depth. Here I pass on the root to it. I pass on the root to it. Okay, and I'll rather broaden the thickness here. So the root that I pass on here is actually optional tree node. Basically what I am saying is either it can be a node, it can contain some value of tree, or it can be 0, it cannot contain anything, it might be containing null, correct? And the return type of this function would be int. Why is it int? Because we need an integer type of length for this tree. Okay, now what I'm going to do is I'm saying if not root. Basically if root is having nothing further, fine, if this is null, if this is also null, then return 0. Okay, return 0 as the integer. Otherwise what you have to do is return 1 plus max of, which is basically maximum of. Anybody who has studied Python for me knows the implementation of this function max. Now maximum of out of two particular, I would say, root left and root right, anything that is maximum fine, out of their depth. Basically I'm using this function recursively. Okay, max depth root of left, max depth root of right. Fine. So that's how I'm using it recursively, and out of these two values, whichever is greater, return it and plus it. Okay, so what I'm doing is basically, let's check it out here. So all I'm saying is, to find out the depth, give the root. Okay, so I said max depth, you give the root 1. Okay, what do I do with this? If max depth is having nothing further, then return 0. It's not like that. It is not the leaf node. Root node is having 2 further nodes. So what I'll do is, I'll go ahead, I'll say, you first of all give me the max depth, or rather I should do this at a new page so that you can get a better clarity of it. Fine, I'll do this at a new page. So here I would write like this: max depth 1. All it says is 1, fine, plus. So 1 plus what? Maximum of, it is saying find the maximum of max depth of left, which is 2, max depth of 3. I'm recursively calling these functions, correct? And out of them, whichever is maximum, fine, out of them, whichever is maximum, add it to 1. This is what basically we are trying to do. Is it clear to everybody so far? Is this step clear to everybody? Tell me. This is just the visual representation of code that I just showed you. Is it clear so far to everybody? If it is clear, then I'll proceed further. Tell me. Is it clear to everybody? Sir, will we do it in Java? Yes, but the logic would remain same. The logic would remain absolutely same. I am telling you the logic. Great. I'll move ahead now. Out of max depth 2, if you see correctly, fine, max depth of 2, if I show you the tree, this is null, fine, this is also null. So this would work. For max depth of 2, this works. So it would return 0 because the depth of 2 itself is nothing. So this would return 0. Okay, 0 is one value and the other value is max depth of 3. So max depth of 3 says, divide it again, because it would basically say max depth of 4, which is one node. The other one is absolutely 0 basically, fine. And out of here you will have 1 plus. Okay, so if I check it for 4, 4 is also a leaf node. It is having nothing here, so it is also null, fine, 2 null nodes. So again this becomes 0. Max depth for 4 returns 0. Why is it so? Because whenever root is having nothing further, it returns 0, correct? So I return it here. 1 plus 0 becomes 1. So this 1 plus 0 equals to 1. This 1 is returned here to max depth of 3. When I return it to max depth of 3, what happens here? Let's check. So this becomes 1, fine. Now out of these 0 and 1, which is maximum? This one is maximum. So 1 plus 1 would become 2, fine. So 2 is the depth. This 2 would be returned here to this max depth, and henceforth the answer would be 2. So the depth is 2. Henceforth, what we were saying initially was that all of you who are watching this, to everybody I told that on the website it is not correct, which is written 3. All of you should follow that depth is 2. Is the logic clear to everybody? Initially it looked a difficult question, but now to all of you who have understood the logic, is it an easy question? Tell me. Sab sikhaunga. C++ I will also explain. I'll explain Java also. Don't worry. I have just shown you the code. I have just shown you the logic. Is it cool to everybody? Sabko samajh mein aaya ye code? I'll go further. I'll explain in Java and C++ also. Great, great. Everybody got the logic. Now let's see it in C++. First of all, we'll see it in Java, as I told you. So this is again the same. All I'm doing is max depth. If you carefully see this code, it is taking tree node as root, the root which we are giving. If root is equal to null, so basically if root further is null, If it is not having anything ahead, fine, then return 0. Correct? Then return 0. If you're having something further, then you return 1 plus math.max, which is basically the inbuilt function in Java for maximum. You use max depth of root dot left, max depth of root dot right, which is the same function. Fine, recursive call. Is the Java code same as the Python code? Just the syntax has changed. Nothing has at all changed. Absolutely nothing has changed. I'm not kidding. Fine. Is it absolutely clear now? Is it absolutely clear now? आदित्य, जावा कोड समझ में आया? टेल मी आदित्य, जावा कोड समझ में आया? Great, great. Now if I go to C++, same thing is happening here. See, all I have done is I've taken a pointer here for the root node. I've just taken a pointer, fine, which is basically pointing to a memory location which is acting as a root node. Okay. Now if root is equal to null pointer, return 0. If it is in the C++ also we have max function which is for maximum. Fine. So all those C++ enthusiast Piyush, fine. Look here, max depth, same again, root pointer left, root pointer right. Same, absolutely same logic. Kuch nahi badla hai. All that is changing is the structure of tree node here. So if you define a binary tree node here, you define a value, you define a pointer to the tree node left and tree node right. So it is just a linked list kind of variation that you're using here. Fine. First structure of tree node. In Java also you're doing the same. You use public class tree node and then you actually declare the tree node left and tree node right. Fine. It is again a class here which you are using. In C++ you are using a structure for defining a single node. In Java you're using a class to define it. In Python also you're using a class to define it. Fine. Where you have a value which is stored in that root. You have a left subtree which is a left pointer and then a right subtree which is a right pointer. Okay. Super easy job, isn't it? It is a basic question, but people struggle with it. The reason is they do not apply the logic. That's why I always tell you, don't run behind the languages. Run behind the logic of it. Language, if you're having good enough command, you can easily solve it. Okay, no big deal. Now, we'll go ahead. We'll solve this question, balanced binary tree. Okay, we'll solve this balanced binary tree because this is a concept which is often asked in government exams as well. Very strange, but it is asked in government exams. What I'm saying is, if this is a tree, which is a binary tree, fine, this is not a binary search tree. I'm again saying it. It is not a binary search tree. Now, here, if I say this, fine, is a binary tree that you have, and at every level, the balancing factor should be 1. It should not be greater than 1. The absolute value of balancing factor should not be greater than 1. Okay. So what is that basically? It is balancing factor is left subtree minus right subtree, fine, longest distance. Okay, the longest distance in right subtree and the longest distance in left subtree. All you have to do is you have to subtract them out, and the factor that comes out for a particular node is a balancing factor. For example, if I do it here, for any leaf node it is always 0. Okay, now if I go ahead, the longest distance in the left subtree is 1 for this particular node, fine, and in the right subtree it is also 1. So 1 minus 1 is 0. This is also 0. And here if I go, it is the longest distance is 1, here it is 2, right? The longest distance anywhere is 2. So 1 minus 2 is actually minus 1, and the absolute value for minus 1 is 1. So this is 1. The balancing factor is 1. You can also, in gate you'll see minus 1 as a balancing factor. So I'm a bit confused in BFS and DFS. No worries, when I'll teach graphs I'll explain this. Don't worry, fine. Depth first search is nothing but you straight away try and find the maximum possible path depth wise where you can reach. If you can't reach, you go back you basically backtrack and check again. In breadth first search, you go by breadth of the basic tree, where you actually look for the every leaf node present at every level. Okay, so don't worry, I'll explain that BFS and DFS in the next lecture. But here, understand about this. I hope the last question, I hope you understood AlgoStrive, and that was basically DFS. It was based on recursive DFS. Fine. So it was depth first search only. Now, in all of this, the balancing factor is -1. So this particular tree is balanced because everywhere you're finding 1 as the balancing factor. Now, if I say this is a tree that you have, okay, this is a tree that you have. In this case, and there is one more node. In this case, what would happen? 0 is the balancing factor for this particular node. For this also it is 0. But for this node, it is, I should say 1. Then for this particular node, what will happen? This is 2 and there is nothing here, so this would be 2. Already it is unbalanced here. Fine. If I check for this particular node, it is -2 due to this. Fine. So this is unbalanced. Fine. This is balanced. You see, whenever 2 appears on any node, it is unbalanced. Anything equal to or less than 1 is balanced. It is clear? Is it clear to everybody? Tell me. Then I'll go to the question. All we need to do is check this. All we need to do is check whether a tree is balanced or not. Is it clear to everybody so far? Oops, important है क्या? बिल्कुल important है यार. चलो, बढ़िया, अगर clear हो गया तो आगे चलते हैं. ठीक है, and balanced binary tree देखते हैं. So here, if you see, this is a balanced binary tree. This is not a balanced binary tree. I have just shown you this same example. Hi Harika, hi, good evening. I have just shown you the 2 examples. Okay. Now what we'll do is we'll use a method again, DFS, depth first search method. You will understand depth first search method better here. Okay. Anybody who's learning from this, again it would be used in a recursive manner. What I'll do is I'll take the screenshot again so that you guys can easily check it out. So shift window S and let's take a screenshot of it. Okay. कॉपी करते हैं इसको और यहाँ पे रख लेते हैं. ओके, तो आई होप कि सबको ये कोड तो क्लियर होगा. ठीक है. ऊप्स जावा में करें या C++ में? यार दोनों ही देखो अच्छी लैंग्वेजेस हैं. एंड ऊप्स इज नेवर अबाउट लैंग्वेज. ऊप्स इज ऑलवेज अबाउट that what exactly the concept is: inheritance, polymorphism, data abstraction, data encapsulation, fine, data hiding. All these things, all these concepts you have to learn in any of the language. So it works, be it C++, be it Java, be it Python, it works. Fine. It's never language dependent. Now coming back here again, now if you see, I have declared isBalanced function to check whether my tree is balanced or not. All I'll do is I'll pass on the root again. Okay, so let's declare a tree here, which is this particular tree. Okay, and this is imbalanced, and this is 1 2 3 4 5. Okay, now I pass 1 as the node here. 1 is the root node, and again optional tree node basically represents that either it can contain a node or it can contain null or 0 as the value. Any playlist or book for reference for oops? Yes, there was one book that I studied in my college times for oops. That was, if I'm not wrong, it was from E. Balaguru Swami, most probably. Fine, so you can check that out. That was a good book. Fine. Otherwise you can check out Prepinsta Prime. I'll show you that. We have all the oops concept covered there. Fine. So I'll log it out, and then if you see here in course list, if you see, you will find oops. All you need to do is you go to subjects, and pardon, in languages also you can go ahead and if you learn any of the languages, you will find the oops concept here. Okay, any of the languages that you try to study, you will find oops concept. Even in the DSA you will find the oops concept, don't worry. Fine. For example, if I show you syllabus for C++, you will have this. Okay, see, oops concept intro, you have inheritance, you have constructors, you have polymorphism, overloading, everything is there. Fine. Which language is best for placements? If you're interested in any of the data AI roles, Python best to go for. If you have done Python for a long time, Python best to go for. If you haven't done any language, then C++ or Java. If you have very less time, again Python. Fine. Go to Get Prime, you select any of the subscriptions, put out the coupon code Shukla10. Fine, so I'll put that out for you. Shukla10, you put this code out, and all you need to do is press here and you'll get some discount. So under this subscription you get all the 200 plus courses including this course, and you can go ahead, you can learn any of the oops concept in any of your favorite language. Fine, this will help you out. Now let's go back to our question that we were trying to solve, balanced binary tree. Okay, so I'll go ahead, I'll show you this. So this particular code, what does it say? I have just taken the code there in my PPT. So here, coming back, so if I tell you that when you're trying to actually check this particular balanced tree, what you have to do is you have to pass on the root node, which is again optional. Either it can be null or it can be some node. This define function is actually of bool type. Fine, so it would return either true or it would return either false. Okay, that's it. Now if not root, so basically if root is null, then you return true and you return an integer value 0, which is saying that basically root contains nothing, so this balancing value is 0. Okay, this is for this function DFS root. Okay, for this particular function you can return this. I have not specified any of the return type for this DFS. Is it clear? Now this DFS root, when I do this and when I go further, what I'll do is I'll go and I'll establish left and right nodes. Again I'll apply the same DFS function, depth first search, on both of them, giving the root node of left subtree and root node of right subtree. Then what I'm saying is you go ahead, you check the balancing factor. What is that? Balanced equals to left of 0 and right of 0, and absolute difference of left of 1 minus of right of 1 is less than equal to 1. If this is the condition, fine, that's how you have to check the balancing factor. You have to basically calculate the balancing factor out of them. Then balanced is 1 plus maximum of left of 1 and right of 1. Okay, so this balanced is nothing but a balancing factor. Okay, and out of this balanced, I'll go ahead, I'll check that out. This will basically return me true or false, right? This balanced would return me true or false. So if this balanced is true, it would be true here, and the balancing factor I'll get here. Is it clear to everybody? I know DSA and C. Is it important to learn in Python? No, but Kavya, you should learn some object-oriented language, be it C++, be it Java, be it Python, because C alone cannot let you handle the concepts of oops. Object-oriented programming concepts cannot be handled. Here we are having a class for this solution. When we were declaring a particular type of tree, we were using this class method, right, which was allowing us to do things easily. Fine, so you should go ahead and learn this kind of object-oriented programming. Now if I go ahead and if I try here, what would happen? So there's no rocket science that would happen. All that would happen is I'll give this to is balanced. So is balanced would have my root 1, correct? What would it do? It would call the DFS of root. So it would call DFS of 1 basically. Now this DFS of 1, if you see, fine, if you see, this DFS of 1 is saying if not root, return true. Basically if root is null, root is not null, my root is not null. So I'll initialize the left or and right of this particular subtree. So what is left? Left is 2 and right is 3. So I'll call again DFS recursively 2 and here DFS recursively 3. Then here also you have to initialize the right and left. So the right portion is null, the left portion is DFS of 4. For DFS of 4 also, one is DFS of null. Fine. And here DFS of 5. Then here DFS of null. Fine. Here DFS of null because it is having nothing. 5 is having no further root. Also here for 2 DFS of null. Fine. And here also DFS of null. Fine. Now it should not give us balanced. It should say that it is false. It is not a balanced tree. I am telling you the logic. Algo strive, it would remain same in Java. This logic, this recursion tree would remain same in Java. Okay. Now, when I go further, when I check for DFS of null. So what is DFS of null? Whenever this root becomes null, return true and 0. Correct. So the balancing factor that comes out here is 0. If you check carefully, the balancing factor would be 0 for it, no? It is balanced. This is true. This is balanced. Fine. Now checking for this node, this is also 0. It is balanced. Checking for this node, this is also 0. Perfectly balanced. If I go ahead and check here, if I go ahead and check for DFS of 4, what would happen? Left of 0, right of 0, and absolute difference of left of 1 and right of 1. Fine. If it is less than equal to 1, which is here, it is equal to 1. If you see. If you see here, if you try finding out the absolute difference of left of 1 and right of 1, what would be it giving? 1 and 0 is there. So 1 minus 0 is basically 1, isn't it? So 1 minus 0 is 1. If 1 minus 0 is 1, what would happen here? This would simply say me that this is 1. Correct. Now DFS of 4 is actually returning this balanced of 1 plus max of left of 1 and right of 1. So here this max of left of 1 and right of 1 was actually giving me this. Correct. Then again out of these 1 and 1, if you see carefully, till this it is balanced. Now when I check the maximum of this range, it would be 2. Correct. This would be 0 here, but here if I check the max, what would happen? This is 0. So this is having no length itself. This is 0 because it is null. So 2 minus 0 would be basically 2. And this time, when for this particular purpose I find it, it would return false in this balanced. Fine. It would return false here now. When the false comes, you will have false for it. Here itself it will say return back, return the DFS of root. So DFS of root is saying false, and henceforth it is not a balanced tree. For is balanced, return this false back, because this DFS of root would have false, and I am returning this same function only. I have defined this function here, I am using this return function here, and it would return false. Simply it would stop. Fine. Simply the whole loop would stop. Pardon, not loop, the whole recursion would stop. It would simply return false because we got balancing factor 2 here. Fine. Easy peasy. Same logic goes in Java. If you see, same, absolute same logic. There's nothing changing here. In Python also it is the same logic. Fine. In Python also it is the same logic. I just explained you in C++. In Python also it is the same logic. All you need to do is, if the difference is greater than 1, it is false. If it is not greater than 1, you have to check the basic of balanced. You basically check the is balanced again. Same thing is happening in both the trees. Is it clear to everybody? Same in Java. You see, left and right I declare, I calculate the differences, out of them I return if both are balanced or not. Is it fine to everybody? Is it fine to everybody? Tell me. Same thing is happening again and again and again. Is it clear to everybody? Tell me. Very easy, not a very big deal. फटाफट बताओ. Tell me in the chat section, yaar. Did you guys get it? Was it easy? आसान था. I know that it is sometimes here and there, but sometimes people don't realize how trees are working, but I've given you the complete logic. So that's pretty much for today. Fine, that's the basic coursework that we had today. But to all of you, बहुत अच्छे से बताया. Thank you, Shubham. Thank you so much. Fine. So great to everybody who understood, and to all of you, I have a homework for you. So let's go to the LinkedIn portion, pardon, linked list portion, which is your earlier homework. So all you need to do is these three questions: merge two lists, fine, remove nth node, and copy list with random pointer, fine. These three questions are your homework. Okay, along with that, in trees you have to find diameter of a binary tree, invert a binary tree, fine. You have to do these two questions, and then you have to do same binary tree. Do not go ahead with these questions. These are tough questions. Do not go ahead with them. First of all, solve these easy 5 questions, fine. This is your homework. This you have to do till the next class. Until then, stay tuned, keep working hard. All the best to all of you. As I always say, keep doing good for others. Good will come back to you, always, in every possible sense. But if you have any doubts now, go ahead, ask me out. I'll clear them out. I can read those doubts in this chat section, so you can go ahead, you can check it out. Sorting algorithms. Okay, so you know what, sorting is not a big deal in any case, because you have, okay, level order traversal or level order TRL is basically level order traversal. I guess you're asking about level order search, like depth first search and breadth first search. So level order traversal is nothing. This is a tree and you basically traverse it in this direction. Okay, okay. Now let me teach you one very important concept which you must not leave. Is your given syllabus in OOPS and C++ is enough for interview and placement? It is more than enough, Mayur. Okay, now let's go ahead and let's study about traversals of tree. I'll teach it today only so that you guys are aware about it. So there are 3 types of traversals, which is pre-order, then there is in order, and there is post order. Okay, very simple. Pre-order is root left right, fine. In order is left root right. Post order is left right root. Okay, as simple as that. Easy है, बहुत मुश्किल नहीं है. देखो, for example, if this is a particular tree, what would I do? 1, 2, 3, 4 and 5. So first of all, root 1, then left subtree. This is left subtree. While traversing it, first of all root again, so 2, then left subtree, which is 3, then right subtree 4, correct, then right subtree 5. So this is basically pre-order traversal. If I do the same traversal for in order, if I do the in order traversal for the same tree, what would happen? Left, so basically left subtree says go to this particular subtree. In this also to the left portion, so 3, then root, which is 2, then 4, then you have 1, then you have 5, which is right subtree. This is the in order traversal. When I do the post order traversal, then it is root in the last, left first, then right. So left is this, so in the left also the leftmost portion is 3, again 3, then the right 4, then the root 2, then again the right portion, which is 5, and then the root again 1. Fine. So these are the 3 particular traversals. This post order is also called reverse polish notation. This pre-order is also called polish notation. Okay, okay, so you want to start the revision. Mayur, simple. Start from arrays. Okay, do only the easy questions, only the easy questions, revise them. Then hashing, then 2 pointers, then stacks, then linked lists, then you come to trees, and then graphs. Okay, that's how the order should be. Okay, that's pretty much about it. I hope everyone is clear about this, and do the homework. Keep pushing yourself harder. Go ahead, explain to people whatever you're learning in my class, and I wish you all the best. Have a wonderful day ahead. Keep doing good for others without any expectations. Good will come back to you. Have a wonderful day ahead. See you in the next stream. Bye bye.